Good day, creators. Welcome to Technical Mathematics. Today's lesson is going to be focusing on trigonometry, on 3D dimension. So that is the topic that we are going to be discussing for today's lesson. And then before we can start, I just want to advise the technical mathematics learners that please, when you revise, use the previous question paper, so that you can learn on how these people they ask questions, especially under trigonometry. And the other document that you should have by now is the examination guideline, and then just go through that document. It's very important. And then it have every question, every topic that you are doing in technical mathematics. The topic that I think is more important for that in that document is Euclidean geometry, because it outlines the acceptable reasons for, remember, when you are answering a question under Euclidean geometry, you need to give a statement and the reason. So there are a specific way of reasoning each statement. So it's very important to just go through that document before you go and write the first paper for technical mathematics this year. All right, and then for trigonometry, I think we also have a trigonometry in that document. Just go and look what are they saying for trigonometry, what are the things that you need to know for trigonometry, especially for 3D, because remember this year we were introduced to 3D dimension, and last year when we were doing grade 11, it was 2D. But this year it was only 3D under trigonometry. All right, and then let's start and see what are we going to be discussing for today's lesson. Under content, we have trigonometry, and this topic, it contributes 50 plus or minus 3 marks for paper 2. Then out of 150, you can imagine how this topic is very important. And then under trigonometry, you'll find the trig ratios and identities and equations. And then you also have the trig functions. And the last one is 2D and 3D problems. But as I was saying, that today's lesson is going to be focusing only on 2D and 3D problems, but mostly on 3D problems. All right. That is that. So let's start and see what are we going to be discussing. The introduction, we have the 2D and the 3D problems. And then you remember in grade 11, we did 2D problems. And then in grade 12, it was a 3D problem. And then from there, you have the first one where you should be able to apply the sine, the cosine, and the area rule in 2D problem as well as in 3D problems. So remember when we were in grade 11, the way we were using or answering question under 2D problems using the sine rule, the cosine rule, and then also calculating the area of a triangle is still the same with 3D problems. So it's the same. So we just have to understand when to use the sine rule, when to use the cosine rule, and how to calculate the area of a triangle. And then number 2, it says solving problem in 2D dimension using the sine rule, cosine rule, and the area rule. So this 3D and the 2D, to me, they look the same. Only difference that maybe in 3D you have more than one triangles, and then but the way we used to calculate the sides or the angle using the sine, the cosine. With 2D, we are also going to apply the same procedure when you are answering question under 3D problems. All right, and then we are going to be looking at these two main triangles before we can start, because we need to remind ourselves on how to calculate using the different type of triangles that we have. Now, the first triangle is right angle triangle. Now, when you are having or when you come across a right angle triangle and you have to calculate the side or an angle, you are going to be using the following theorem of Pythagoras. Remember that we learned that early grades, where you don't have one side is unknown and then you have two, you are given two sides, then we have to use theorem of Pythagoras. And the other one is ratios, trigonometry ratios. They are you can see them next to this right angle triangle. We have sine theta equals to y over r, cos theta equals to x over r, tan theta equals to y over x. So it's very, very important to know which one to use which one when you are calculating maybe a side or an angle. So it's very, very important. And then for instance, if you are given angle, let me just show you something. If you are given angle on this side, we have angle theta there. Then we always know this side, which is opposite to that angle, we call it opposite side, which is y, all right? And then sometimes it happens that the angle it is in this side, and then if the angle is in this side, then this side now changes to become what? Opposite. So every time when you are dealing with the right angle triangle, you must be very careful, especially with the angle that we are working with. So the opposite side of that angle is always our opposite. And we know that the sine theta equals to opposite over adjacent. That one you should know. Cos theta equals to adjacent over hypotenuse. Of course, tan theta equals to opposite over adjacent. So you should also revise those trigonometric ratios. And then when you have a non-right angle triangle, any triangle which does not have 90 degrees or it's not right angle triangle, we use the following sine rule, the cosine rule, and calculating what the area of a triangle. Then we'll be talking, or I will be explaining on how do you calculate the area of a triangle, when to use the sine rule, when to use the cosine rule. I think today's lesson is going to be emphasizing on that point because it's very, very important. All right, now let us deal with the conditions, because there are conditions before we can use the sine rule, before we can use the cosine rule, before we can calculate the area rule. You need to first learn these conditions, because you will have a 3D diagram where you need to calculate a side. But now, if you don't know the conditions, when to use the sine rule, when to use the cosine rule, or how to calculate the area, then it's not going to be possible for you to calculate that particular question. So, but first, it's very important that we learn or we study these conditions, so that when we have to answer question under 2D or 3D, we know which formula is suitable to answer that question. Now, the first condition for us to use the sine rule, it says you must give two sides and one angle that is not between the two given sides. That's number one. Number two, give two angles and one side. So those two conditions are for sine rule. When to use sine rule, you must have two sides, one angle, which is not included, which is excluded. It's not between the two given side. And the other condition says giving two angles and one side. All right. And then cosine rule. Let's see under cosine rule what we have. Having all three sides, there you use the sine rule, or giving two sides and one angle that is between the two given sides. Please don't convince the two. This one of cosine rule, it says you are having two sides and one angle which is between the two given sides. All right. the area rule. Under area rule, we have the condition. The first condition says give two sides and one angle that is between the two given sides. You can see this one is the same as this one of cosine rule. So in order for us to calculate the area of a triangle, we need to meet this condition that says we must have two sides and then one angle that is between those two given sides. All right. So that these are the condition for sine, cosine, and the area rule. So please let us go through this and learn first the conditions so that before we can go and answer questions under 2D and 3D. The first one is the sine rule, the sine rule formula, which is A over sine A. You can see that this angle, the opposite of this angle A is small a, this side is small c, this side is small b. So now this is the formula that we are using to calculate side or angle using the sine rule. So I'm going to have one example where we are going to explain or get used to this formula of sine rule. It says use the information in triangle ABC to find the length of AC, round your answer to one decimal place. You can see that in this triangle we're having two angles and one side. So you should remember which condition is this. This one is sine rule, and then now you write the formula sine A over, because now we are in need of this side. Let me just explain this one. We are in need of this side AC. Therefore, angle which is opposite to this side is small b. Hence, we are having b there. This we are having b. And then this one, where you are having an angle and a side, opposite side, which is 6 centimeter there, is a with a small a. Hence, we are having a there. We cannot write sine c because we don't have an angle. We don't even have a side. All right. Then from there, you substitute the values. Thereafter, you cross multiply, then you're going to be dividing with sine 46 degrees. Then you just press your calculator, and the answer is 7.1 centimeter, not this one, because the instruction is very clear that we should round off to one decimal place. So the answer is 7.1 centimeter. So that is for sine rule. And then we go to what is this one? Cosine rule. We're having cosine rule now. Let's have an example under cosine rule. In the following triangle, calculate the length of AC, write the answer to two decimal place. Let's see what we have. We're having two sides, 1 and 2, an angle which is between the two given sides. You can see this condition it is for cosine rule. So now we are going to be calculating which side. We are now calculating this side, AC, which is small b. Then now we have to write the formula as b squared. Actually here it was just a typing error. It's supposed to be b, not d. This is b because this side is small b. All right, now this is the correct formula to calculate that side AC. Then the next step, you substitute. You can see that after substituting there, you can take your calculator and press everything in your calculator there, and then it's going to give you this 6.76. And please, before we can reach to the final answer, don't round off before we reach to the final answer. We only start rounding off at the end of everything else. For now, just put everything on your calculator there. Thereafter, you put square root both sides so that we can get rid of this exponent 2 because we're in need of b. Then we say b equals to 8.05 units. So that is the value of AC. So the length of AC is 8.05 units. Then we are now into area rule. How do we calculate the area of a triangle? Let's see on how do we calculate that. I just want to explain this area. The first one, because you'll find our learners are struggling in terms of writing the standard formula for the area. But let me just explain to you. The first one says area of a triangle ABC is equals to 1/2 BC sine A. Meaning, if this is this area, it says 1/2 B small c. Remember, we have small b, small c. That tells you that in that triangle, you must have this angle. You must be given this angle here. You must also give in this side C. You must also be given this side B. Because remember, the condition says you must be given two sides and then one angle which is between those two given sides. So you must have that. The hence is like this. This number 2 AC sine B, A and C, meaning you must be given this angle and this side A and side C. And the last one, AB sine C, you must be giving B, A and B and this angle C as well. Now let's look into this example. We can see that we are having side C and side A, and then side, and then here's going to be what? Supposed to be B, not what? Not D. And thereafter you write the formula. Area equals to 1/2 AC sine B. And then from there you substitute the values, and then you press your calculator. Then the answer is 48,18 units squared. It must be units squared because you are calculating the area. So to show that is the area, you should write units squared, unless we have the units there. Maybe if, for instance, if we had centimeter, the answer was supposed to be a centimeter squared. But now, since we don't have any units, you write the unit squared to show that we are calculating the area. All right, in the diagram below, AB is a straight line. We can see AB is a straight line, high 1,500 meter long, and this is a vertical tower, 158 meters high with the point C. A and B on the same horizontal plane. The angle of elevation of D from A and B are 25 degrees and theta respectively. It is also given that C angle AB equals to 30 degrees. Now let us address the following questions. Let us answer the following question. The first one says determine the length of AC. Where is AC? This is the AC. This is AC. Now you can see that AC is part of triangle DECA and ABC. Then we are going to have to choose between the two angle, which is triangle 1 and 2. Which triangle can you use to calculate or be able to calculate AC? You can see it's not possible for us to take triangle ABC because we only have what? We only have the angle and a side. So we don't have anything. And then there's no way we can use the sine rule, the cosine rule, or maybe to use the trig ratios. And of course, the trig ratios, it is only applied to a right angle triangle. And that this ABC is not a right angle triangle. And then that means it's not possible to use that triangle. But now let's look into this triangle DCA, ACD. You can see it's a right angle triangle. And then what are we having there? Let me just remove this. We can see we're having an angle which is 25 degrees. And then there's also the opposite side of that angle is 158. Meaning, and this is right angle triangle. We can now use the trig ratios, but now which trig ratio is suitable for this one? Let's see how to write this. So it's tan theta because why? Tan theta equals to opposite, which is 158, divide by adjacent, which is AC that we're looking for. That hence you see AC is denominator, and then after you cross multiply, and then after cross multiply, you divide with tan 25. This is what you're going to be having. Then after this, you just press your calculator, and then you're going to get 339 meters. So that is the length of AC. The second question, determine the length of BC. Determine the length of BC. So where is BC? This is BC. This is BC. So how do we determine that length? Now, we can see that triangle BDC, we have only this side, which is 158. We don't have angle. The angle is unknown, so it's not possible to use that triangle. What about triangle ABC? Yes, you can be able to use, because now we are having, remember we have just determined this side, which is 339 meters. We are now having two sides and one angle which is between those given sides. Then obviously we're going to use the cosine rule. We're going to use the cosine rule. And then after that, you just substitute the values. Then you press your calculator there. Then after pressing, remember what I said about after pressing calculator, you don't round off, you write those numbers the way they are from the calculator. And then from there, you put the square root both sides, because you have to get rid of this exponent 2, because we are calculating BC, not BC squared. And then after doing this, you just press your calculator, and the answer is 1,218 meters. That is the length of BC. All right. And then number 3, find the value of theta. Find the value of theta. Let's see which theta are they referring to. Right, we can see that theta that we are calculating is this theta here. We are calculating this theta there. So remember, we have just determined the length of BC, which is 1,280. We are also having this side of 158. And then obviously we're going to use the tan C, and then from there, and then you press your calculator, shift tan this 158 over 1,280. It gives us how much? It gives us 7,39 degrees. That is the angle that we have just determined. And then number 4, calculate the area. And then let's see, we are going to be calculating that area the next slide. All right, now let's calculate the area of the triangle ABC. Remember, for us to be able to calculate the area in that triangle, we must have two sides, one angle, which is between those two sides. Yes, its area equals to 1/2 small b. Remember, this is going to be a small b. Small c is this side, and then we have angle A, right? Remember, we have determined AC. We know the length. It was 339, and then this length AB is 1,500. You just substitute the values, and then from there you press the calculator, and then the area is 127,125 meters squared. Remember, the unit is also important. This one is unit squared. It's not unit squared, but it's meter squared, because we have the units there. Calculate, find the length of AD. Where is AD? It's this one. Now we are looking for this. We are looking for this AD. You can use theorem of Pythagoras because already we have the length of AC, and then DC we have the length. You can use theorem of Pythagoras. You just substitute, put square root, and then from there it gives us 374 meters. That is the length of AD. Then calculate the size of A angle DC, meaning we are in need of this angle here. We want this angle D. So let's see. A angle DC equals 180 minus 90 minus 25. Why? Because this is a triangle DCA. So you add the two given angle, and then you subtract them from 180. They can give us that angle, which is A angle DC, which is 65 degrees. So that is the answer. All right. AB is a vertical tower. CD are points in the same horizontal plane as B. The foot of the tower AB is 30 meters, and the angle of elevation of A measured at D is 40 degrees. A angle CD is 35, and then A angle DC is 45. It's not 45. That is 100. Supposed to be 100, not 45. A angle DC supposed to be 100 there, not 45. Let's see the question. Calculate the distance between the point C and D. The distance between point C, meaning we're in need of this. We want this one now. We want this angle distance. And let's see. We start with the triangle A, B, D. We can calculate so that we can be able to calculate this side. We want to calculate AD. So what are we going to use? We're going to use trig ratio of sine, and then we then cross multiply, and then you divide with sine 40, then it's going to give us 30 over sine 40. You press your calculator, and the length of AD is 46,67. So this side is 46,67. And thereafter, we go to triangle ABD. ABD. No, it's not ABD. It's supposed to be triangle ADC. Triangle ADC. Triangle ADC. All right. Triangle ADC, not ABD. And then now we just use the. We are going to use what? A sine rule, because we are having DC. Let's check. DC is what we are in need of, and then AD we just determined, which is 46,67, and then this angle here is 100, and then this angle there is 35. And then DC is equals to, let me see if it makes sense. And does it make sense? It does not make sense to me. Let's see, and then from there you press your calculator. The answer is 80,13 meters. The distance of AC, let me check. All right, I think there is a mistake on this question. If I calculate the distance between the point C and D, DC, you can see the distance. Then if we have the angle here, this opposite, remember this side we just determined AD, which was 46,67, and then we also have this angle here, which is how much? 100. But now for us to be able to get DC, we must have this angle here, so that we can now calculate that and see. Now let's see what is that angle. 180 minus 100 minus 35 is 45. No, that's correct. A angle, this is supposed to be D angle AC is 45. That 45, it will come here. So there was a mistake. That 45, this is not supposed to be A angle DC, but now is D angle AC is equals to 45. All right, it's equals to 45. Now, if that is the case, then we need to refix this. We are not supposed to use 100 here, but we're supposed to use what? 45. We're supposed to use 45. So here is supposed to be 45, not 100. So we're going to be recalculating this. Let's see on how do we calculate that one. Then after doing cross multiply, we remember here is no longer 100, but it's 45. Let us try to fix this question. It's 45. Now let us recalculate this one, and then we say what? 46,67 sine 45, right? Divide by sine 35. Then our answer, the correct answer is no longer 80, but now is 57. Is 57,53 meters. 57,53 meters. All right. Determine the area of triangle ADC. ADC. Let us calculate the area ADC. I think it's also going to affect the area because AD, where is AD? AD is this side. DC is this side. All right. And all right. Now we only have to change this side. DC is no longer 80, but is 57. 57,53. Now the sine 100 is still 5. Now let us recalculate the area of triangle ADC. So you say half multiplied by 46,67 multiplied by 57,53 times sine 100. Now the correct area, now let us just cancel this one, is 1,322,007, right? Meter squared. 1,222,007 meters squared. That is the correct area. All right. Let's now proceed. All right. The diagram below shows the position of a helicopter at point P, which is directly above point D on the count. Points S, D, and T lie in the same horizontal plane such that points S and T are equidistant from D. PD equals to 70 meters and S angle DT equals to 117 degrees and S angle PT equals to 32 degrees. And then let us try to answer the following question. Calculate the following distance. The following distance, which is ST, SD. Let us determine SD. Let us determine SD and see what to calculate. Where is SD? Is this one? We have to calculate this one. All right, now let's see what to use. We are using the trig ratio of tan. Why? Because now we can see it's only triangle PDS where we can use the trig ratio because we have the angle and the side. Now, this is what I was explaining earlier on, that if we are having angle on this side, you can see this angle there, then this side of SD becomes the opposite now, and then this side of 70 becomes adjacent. So that's why you see 70 as denominator there. Then from there you cross multiply, and then you press your calculator. Then the distance for SD is 44 in terms of to the nearest meters. So it's 44 meters. All right. And then if this is 44 meters, and then this side DT is also 45 meters, because we were told from the scenario that they are equidistant. They are equal in terms of the distance. Now calculate the distance of ST. Then we want this one now, ST. And let's see what are we going to use. SD and ST is equals to, no, there is a mistake there. This is supposed to be DT, not SD. DT is equals to 44 meters, all right? And then from there, we are going to use we are going to be using what? The cos rule, because we're having two sides and then one angle which is between, which is this angle is 117, and hence we use this one of cosine rule. Then from there you substitute the values, you press your calculator, you put square root both sides to get rid of that exponent 2, and then the answer for ST is 75 meters. So that is the answer, is 75 meters. That is the correct answer. Now, determine the area of what? Triangle SDT. This is the area. And then when you look into that triangle, do we have two given side and one angle which is between? Yes, it's 44, 44, and the angle is 170. We can be able to calculate the area of that triangle. Then from there you substitute the values, then you press your calculator. Our angle is, our area is 862.49 meter squared. The diagram below represents a person standing at the point A on top of the building AB, which is 50 meters high. He observed two buses, C and D, that are in the same horizontal plane, SB. The angle of elevation of A from C is 55, and the angle of elevation A from D is 55 as well. C angle A is D equals to 65. Calculate the length AC to the nearest. We need this one, AC. We need AC. We can now see that we can be able to use ABC in order to calculate the side AC. We are going to use the trig ratio of sine, because we're having angle and opposite angle, and we want the hypotenuse side. Then hence we do that. So we cross multiply, thereafter you divide with sine 55. And then we have 50 over sine 55. You press your calculator, it gives us 61 meters, that length. And then from there, calculate the distance to the nearest meter between the two buses, meaning we want this distance DC. Let us calculate the distance DC. Then we say AD equals to 61 meters. We're still going to use the trig ratio of sine to get the length. Now remember, we also have to calculate this length here. And then we say it's also 61. Why? Because let us look at the triangle ABCD. We also have the angle, which is 55 as well. And the side of that, opposite side of that angle is 50 as well. So if we have to calculate the distance AD, it's going to be the same distance of AC, which is 61, all right? And then now we can see we're having two sides and then one angle which is between those two given sides. So for us to calculate DC, of course, we are going to use the cosine rule. Then you write the correct formula for the cosine rule. Then you just substitute the values there, and then you press your calculator. And then you put square root both sides so that you can get the value of A, not A squared. And then the value of A equals to 66 meters. Therefore, the distance between the two buses is 66 meters. All right. If the area, this is area, if the area, not this one, supposed to be area, this is area, not that. Let me just fix it for you. This is area, right? This is area. It's just that my pen does not write very well, but that is area, people. I hope you all understand. It's supposed to be area. I will just write A, just to show its area of triangle ABC is 563 meters squared. Calculate the size of B angle DC, meaning the end of this angle here. Then now, and then we are already being given the area, so we need to calculate this area there. And then we don't have what? We should have the length BD and the length BC, so that we can meet that condition that says we should have two sides and one angle, which is between those two given sides, so that we can apply the area rule. But now let us first calculate the length of DB, BD, then we use the trig ratio of tan, cross multiply, you divide with tan 55, you press your calculator, then it gives us 55, 35 meters, and thereafter you then write this area, and you substitute the value. Area, remember, is 563, 1/2, DC is 66, BD is 35, and then sine B angle DC. Then you divide with this, then you are left with this one. Then from there you write this one, you divide with sine. Then from there you say shift from your calculator, shift sine this fraction, and it gives us the angle as 29.17 degrees. So that's how you should determine the area, not the area per se, but the angle, or angle B angle BC, when you are given area. So this was a very interesting question. So let us try to get some questions which are similar to this one, so that we understand. If it happens that we come across this kind of a question, we know how to calculate it. AB and A are points on the same horizontal plane. HL is the vertical pole of the length of 3 meters, and then AL equals to 5.2 meters. A angle LB equals to 113, and the angle of elevation of H from B is 40 degrees. The first question, calculate the length of LB. Where is LB? And then this is LB. This is LB. Let's see what to calculate. We're going to use the trig ratio of tan. Then you substitute the values, you cross multiply, you then divide with tan 40. You then press your calculator, and the length of LB is 3.6. All right. Hence, or otherwise, calculate the length of AB. Where is AB? This one. And we want from this point up to this point. we can see we've just determined AB. We also have AL, and then we have angle between those two given sides. And therefore, we're going to use the cosine rule. You write the formula, you substitute, you press your calculator. Then because it's L squared, we need to get rid of that exponent 2 by putting a square root both side. And then from there, the answer is 7,4 meters. The length of AB is 7,4 meters. Now, the third question, calculate the area of triangle ABL. ABL. Then you write the correct formula for the triangle, for area, I mean, and then you substitute the values. Then the area is 8,6 meters squared. Area is equals to 8,6 meters squared. That is the area. All right, thank you very much for being with me on this very interesting lesson. I hope whatever that I discuss with you is going to have an impact on you while you are busy preparing for this coming final exam for technical mathematics. Let me just once again remind you, please use the previous question paper for revision purpose. And then let me just leave you with that says study like there is no tomorrow, because if you keep putting off your studies for tomorrow, you'll probably be late. All right. Thank you very much. Have a nice evening. Bye.